Alright, so from the textbook, page 303, number 106. So 106 says the directions are, in 106 and 107, find f of g of x and g of f of x and determine whether each pair of functions f and g are inverses of each other. So 106, f of x equals 3/5 x plus 1/2, and g of x equals 5/3 x minus 2. So find the composition, one inside the other, and determine if they're inverses. So what we should know is that whenever you substitute one function inside another, if it simplifies down to x, then they are in fact inverses. If they don't, then they're not. So we're going to do f of x, or f of g of x, and then we're going to do vice versa. So f of g of x. Okay, I'm going to start writing down the function f of x, 3/5 times x plus 1/2, but in place of x we're putting in g of x, which is 5/3 x minus 2. I'm going to distribute my 5/3, or my 3/5. So 3/5 times 5/3 is 15/15, or 1, so that's just x. And then 3/5 times -2 is a negative, 3 times 2 is 6, so 6/5 plus 1/2. That does not equal x. So I think it's safe to say that they're not inverses. I'm going to go ahead and do what the book is asking me to do and do both. Because like I told you before, they tend to require both in order to prove. So we'd start with the outer function g, which is 5/3 times something minus 2. And that something is f of x, and that is 3/5 x plus 1/2. So if we distribute the 5/3, 5/3 times 3/5 is again 15/15, or 15/15 x, so x. And then 5/3 times 1/2 is 5/6 minus 2. That does not equal x. Therefore, f and g are not inverses. Okay? Number 107. Similar problem. F of x equals 2 minus 5x, and g of x equals 2 minus x over 5. So I'm going to do f of g and g of f. So f of g and g of f. So f, I'm going to start with the function 2 minus 5x, so 2 minus 5 times x, but x is 2 minus x over 5. So if I simplify this, the negative 5 times this, well, okay, I'm going to go ahead and simplify the 5 divided by 5. 5 divided by 5 is 1. But I am subtracting, so it's 2 minus the quantity 2 minus x, which equals 2 minus 2 plus x. And the 2 simplify out, leaving with just x, so that is promising. And then g of f, so g of f, I'm going to start with the function g. 2 minus x over 5, but x is f of x, which is 2 minus 5x. So we're going to go ahead and distribute this minus sign in the numerator. 2 minus 2 plus 5x divided by 5. The 2 simplify out. 5x divided by 5 is just x, and there we go. Therefore, f and g are inverses. Just poor handwriting all around. Okay. Are 111. So 111. It says, represent which graphs in exercise 111 through 114 represent functions that have inverse functions. Okay, so I'm going to sketch these functions on my paper and then go from there. Which graphs represent functions 5 that have inverse functions. So one thing to remember is that the only way that your inverse is going to be a function is if, don't forget that, is if you are one-to-one, which means you have to pass the vertical line test. So first you have to be a function, so you have to pass the vertical line test. But then in order for your inverse to be a function, you also have to pass the horizontal line test, which means you have to be one-to-one. So number 111 looks like the left side of a parabola that passes the vertical line test, and it passes the horizontal line. It passes the vertical line test and the horizontal line test, so that would be, I guess I'll just say yes. I'm going to put inverse will be a function. So number 112. 112, you don't know this yet, but 112 is actually tangent-ish wave. It is tangent. So it does something like this. And what you can't tell is it actually has vertical asymptotes. Here and here and here and here. Looks like just a bunch of cubics over and over and over. But anyway, so as far as tests go, it does pass the vertical line test. So vertical line test, check. But horizontal line test, it fails. So the inverse will not be a function. Inverse not a function. Now that doesn't mean we don't have the inverse to a tangent. We can actually graph a tan inverse, but we have to limit, we have to restrict the domain of the original. So 113. 113 looks kind of like a cube root, actually. So it's something like this and like that. So it does pass the vertical line test. And it also passes the horizontal line test, which means the inverse will be a function. And number 114 looks like a semicircle. And a semicircle, while it does pass the vertical line test, it does not pass the horizontal line test, which means the inverse is not a function. Alright, now we have page 305, numbers 3, 31, and 33. Okay. How many use the space for number 3? Check out 31, 33. 31, 33. Cute. No, okay. I don't know if I have space. We'll see. I'm gonna have to squish. Okay. I should have thought that was a lot smaller. Oh well. So, whoop, number 3. I've got a graph. Whoop. So I go to the right 2, to the left 2, and down 2. And I'm going to plot those points. And this is my function f of x. Okay. So all right. Part A. It says, what are the zeros? So zeros are where you hit the x-axis, and so it looks like it hits the axis at -2, 0, and at +2, 0. B. Find the values of f of x for which f of x equals -1. So f of x equals -1 at x equals what? So if I look at this graph, this looks like it has a slope of up 1 over 1, so up 1 over 1, up 1 over 1. So when I look at when does this equal -1, the y value -1, that would be at 1 and -1. So x equals plus and minus 1. Part C, find the values of x for which f of x equals -2. F of x equals -2 at x equals what? So it looks like it only equals -2, the y value -2, at x equals 0. Because that's where that point is. Part D, is f even, odd, or neither? So even functions are symmetric across the y-axis, so they can, like, a quadratic is even. Odd is symmetric about the origin, which means like x cubed is odd. You can rotate 180 degrees, and neither would be neither. This has even symmetry, kind of like a quadratic does. So we would say that this is even. I'm not going to worry about that, so that means you don't need to worry about that right now. Okay, E. Does f have an inverse function? So the only way that the inverse is a function is if this function is 1 to 1, and that would be a no, because it fails the horizontal line test. You draw a horizontal line across it more than once. All right, F. Is f of 0 a relative max, min, or neither? Relative max, relative min, neither. And this f of 0 is the y value at x equals 0, and f of 0 is -2. And so I would say -2 is a relative min. It's the lowest that it goes in this region. Okay. All right. Part G. So G is graph g of x, which is f of x plus 1 minus 1. So that means take the function and shift it left 1 and down 1. So that means just take it, lift it in, so 1, 2, 3, and 1, 2, 2, 3. So I'm going to take the function, I'm going to take this first point, and I'm going to go left 1 down. So left 1, so it was here, now it's here, down 1, which puts it right here. And take this function, go left 1 and down 1, which puts it at 1, -1. And then I take this function and go left 1, down 1, which puts it at 1, -1, -3. And there we go. GH. So H is graph, interesting, 1/2 f of 1/2 x. So that is a vertical compression by a factor of 1/2, but a horizontal stretch by a factor of 2. So when I sketch this graph, 1, 2, 3, 4, 2, 2. Okay. So let's first address this. Vertical compression by a factor 1/2. The original function goes down 2, which means we're only going to go down 1. Now, horizontal stretch, the original function goes to the right 2 and to the left 2. If you stretch that by a factor of 2, that means it's going to go to the right 4 and to the left 4. So it's horizontally stretched, but vertically compressed, which means that would be my function. Okay, HI, graph R of x, which equals negative f of negative x plus 1. So let's talk about those transformations. The first thing you would have to do is flip over the y. And then you have to flip over the x, and then you'd have to go up 1. So 1, 2, 3. But we can do those flips at the same time and then shift it up 1. So okay. First off, flipping it over the y. If I take this function and I flip it over the y-axis, it has even symmetry, which means flipping it over the y isn't going to change anything. It's already symmetrical about that, so that doesn't matter. Flipping it over the x, however, would mean that instead of being down here, it's up here. So I'm going to kind of ghost that. It would be here. But then I'm going to shift it up 1, so my final answer would be here, here, and here. And so that would be my graph. And then IJ. So average rate of change from x1 equal negative 2 to x2 equal 1. Okay, so that is actually just asking me to find the slope on this interval. So remember, the slope formula is y2 minus y1 over x2 minus x1. So I'm going to go ahead and y2 minus y1 over x2 minus x1. So the x2 is 1, and the x1 is negative 2, which means if I want to find the y values, I got to plug them in. So if I plug in 1, or if I just look at it, at 1 the function is negative 1. So y2 is, or sorry, yeah, so I got a negative 2. So when x is 1, y is negative 1. Minus, when x is negative 2, y is 0. Over x2 minus x1. So it'd be negative 1 minus 0, which is negative 1 over 1 plus 2, which is 3. So the average rate of change is negative 1/3. And that's number 3. So let's look at number 31. 31 is, it says find the domain of each function. So all I need to do is find the domain of 3 over x plus 5 plus 7 over x minus 1. So that one is just, oh, sorry. This one right here, domain issues, I've got fractions. Okay, so x cannot equal negative 5 and x cannot equal 1. So my domain is negative infinity, negative 5, negative 5 to 1, and 1 to infinity. And there we go. Number 33 is if f of x equals 7 over x minus 4 and g of x equals 2 over x, find f of g of x and the domain of f of g. So f of g of x and domain. Alright, so I'm going to start with the outer function f of x, and I'm going to substitute in g of x, which is the inner function. And I'm going to talk about domain as I do this. So let's not forget that when we want to find the domain of a composition, we have to start with the interior function. G, x cannot equal 0 because 2 divided by 0 would be undefined. So that is part of my domain. Okay. F of g, I need to start, so the second step is to do the composition. So 7 over something minus 4. And that something is 2 over x. So I'm going to multiply numerator and denominator of 4 by x. I'm going to multiply by x here, and I'm going to multiply by x here. And that, so that leaves me with 7, which is the same thing as 7 over 1, over, how was it?
Definition derivative. I don't know if I already did that stuff there.
Okay, we'll see. Where's the test?
Oh, I just left it.
Okay. Just over here. Okay, so the denominator I'm going to combine to 2 minus 4x over the common denominator x, and then I'm going to flip and multiply by x over 2 minus 4x, and simplify. 7 times x is 7x, and then 1 times 2 minus 4x is 2 minus 4x. So remember, when we're finding domain, the first step is find the domain of the interior function. We did. X cannot equal 0. The second step is to perform the composition and simplify, and we did. And then the last step is to determine if there are any extra domain issues because of the denominator, a new denominator, new square root, whatever. And we do have a new issue. 2 minus 4x cannot equal 0, which means negative 4x cannot equal negative 2, which means x cannot equal positive 1/2. So my final function is this, and my final domain is negative infinity 0, 0 to 1/2, and 1/2 to infinity. And there we go.